Hey there, I'm Himanshu Gupta, currently studying Electronics and Instrumentation Engineering at BMS College of Engineering. I'm really into data science, especially machine learning. I have worked on cool stuff like creating a system to detect fake news, and you can check out the project details on my GitHub profile. I'll provide the link in the description. Apart from my studies, I enjoy coding and I have reached a two-star rating on CodeChef, which means I'm pretty comfortable with different programming languages. I've also been part of open source projects, contributing a bit to the tech community. Now, to level up my skills in machine learning, I'm excited about joining the fellowship program at fellowship.ai. It is a fantastic opportunity to dive deeper into the world of artificial intelligence, learn more, and make some meaningful contributions. Looking forward to the journey. And for today and for this video, I've created a project which was assigned by the fellowship.ai, which was based on the natural language processing, and it is sentiment analysis on a 50,000 dataset movie reviews. So I'll continue with the project, and this was my little introduction. And to continue with the project, I'll go on the Google Colors. So I'll explain the project. Thank you. So hello everyone. So we continue with the project. So firstly, we do this project by in four steps. First is data preprocessing. First step we are going to do is data preprocessing. Second is vectorization, means bag of words, and then third is train the data, and fourth is deploy the model. Okay, so we'll firstly include these pandas library and numpy library. Import panda as SPD and import number as NP, import Swifter. This Swifter I'll explain later in the video why we include this. And read the data which we included, which was given by fellowship.ai. So we read the data as pd.read CSV and we include the file name, file path. And then after that, we do that, we check the head part. So df.head. So we'll get the head part, what it looks like. So our data is look like this, review is given and sentiment is given, positive and negative. Now, now we'll check the first review, means first row of the review column. So this is how it looks. Now we'll move to the data cleaning part. So to clean the data, firstly we check its info. So df.info. So it's give the whole values in the data. Now we'll move on the next part. Like we have given here sentiments in positive and negative. So we have to convert that into 0 and 1. So because we train our model on the numbers. So, so we'll convert that positive and negative into 1 and 0. So this df sentiment dot replace positive 1 negative 0 and place true. This will help in converting positive to 1 and negative to 0. Now again we check our data. So it comes into 1 and 0. So positive and 1 and negative and 0. So it helps in to train our model, because all every model is to be trained on numbers, not in strings or words. So every word or string will convert into numbers, vectors. So after that we move into removing all HTML tags using RE. So RE is a library, regex library, which is used to clean the data by means clean all the HTML tags from our data, like all these which are written here. And now this is a function we are used to clean our data. RE dot sub clean comma this all we are doing. So it clean our data. So after cleaning our data, we'll take a look at that by writing df review is equal to df review dot apply clean HTML. Means we are creating a function which apply to all rows in the column review. Okay, so after cleaning the HTML text, we convert all the text in the review column into lower case. So we'll create a function convert lower text return text dot lower. So it convert and then we apply it to whole column, means all rows in review column. So it convert all the text into lower. Now after that we create a function remove special. Remove special means this is the function we create for characters which are coming. Okay, so we continue with the remove special. So we pass the text into the function. So what we are actually doing here is that first we check our row, is there any special character or not. If there is, then we'll going to remove that. So to remove that special character, we're gonna check every word by making a loop. So for I in text, if I is alphanumeric, then x is equal to x plus I, means we are declaring an empty string here. So we'll concatenate that concatenate that special that word into the string. If that word is not alphanumeric, then we'll pass the uh, space string into the our x string which we was declared, and after that we return the x in the last, and after that we'll apply that to all the column, means all the rows in the column of review. Dot apply review special remove special. So we'll remove all the special characters from our text. Then after that we'll move toward to the stop words, like removing stop words. Stop words is what? That I am the and all the characters we know, so that are stop words. So we're going to remove that. So firstly, we'll import the library. So from NLTK corpus, import the stop words. So after that importing, we'll create a remove stop words. And, here also we will take the text, and we are creating an empty list. So what we are actually doing here is, when in our text we are creating a list of the words. If words are not in a special and not in a stop words, then we'll append into the list. Otherwise, it will skip that. Then after that we'll create a list x, y is equal to y becomes x of list of words, and after that we clear the x, and at last we return y. So every row we are doing this in the review section, review column. So we are using df review is equal to df review dot shifter dot apply this. Shifter we are using here is because it decreases our runtime, because it is running our data in parallel. So we are using this library import swifter to include this swifter in our code, so our time will be shorter, running time will be become shorter. Okay, so now after doing all these, we remove all the stop words, we'll remove all special characters, all the stemming is done, and all html tags are removed. So after that we'll get this data, so you can see that. And from NLTK stem porter import porter stemmer, yani, means we are going to do stemming this time. So, okay, so stemming is doing this time after stop words. So what stemming is, we are going to remove all the similar words like love, loved, loving, and so we create a single word by making them all same, like love, loved, loving all becomes love. So again we'll create a function for that, and similarly what we'll do in stop words, we do the same here. At every row we are doing to apply stem words by dot append stem ps dot stem I. So same as the stop words, same function, only stemming are doing here, and same we apply all in all the rows after that. So after that we'll get this data, as you can see. After that we'll join all the words, like here we'll create a we'll, we'll create a words which are in list. So for that again we are going to join, like making it a sentence, a, a one line sentence, not a list. So to join a list, we are going to run this function, create this function, join back list input return. This is a basic function in Python. uh, dot join list input, and after that we'll return this, we'll apply it to all the rows after that. And after that our last operation is going to be count vectorizer. It means it counts all the unique words in the data, in the review section in our text. It going to take a unique words only. So after applying it, we'll see that x dot shape becomes 50,000 comma 500, and y dot shape is 50,000. And after that we'll apply our model. So firstly we'll give some values to split our data into x train and x test, y train and y test. So we are going to split our data. So what we are after splitting, what we get is x train is 40,000 comma 500 and x test is 10,000 comma 500. Similarly y train dot shape is 40,000 and y test comma shape is 10k. After that we apply a naive Bayes model. So in naive Bayes model, I actually test all the models. Among all of that, naive Bayes is best among that, so I'll include that one here. So naive Bayes is actually have three. Actually, naive has three classifiers. So Gaussian, NB, multinomial, and Bernoulli. So all of three we are going to test. So firstly we fit the data into our model, and then we predict our values. So here we call the function Gaussian NB, we call the function as CLF1, and multinomial NB as CLF2, CLF3, classifier 1, classifier 2, classifier 3. Three classifier. Firstly we fit our data into Gaussian, then into multinomial, then into Bernoulli. After that, fitting, we predict the data by taking the x test into uh, by Gaussian, by multinomial and Bernoulli. After that, we will get y test dot shape is 10,000, y predict one dot shape is 10,000, and after that we'll include a scikit from the scikit library. We'll include the accuracy and score. So for all the three classifier, we'll get the accuracy score. So for Gaussian classifier, we'll get 80% accuracy. For multinomial, 82%. Monoli for 82.4%. So best of among all these three, we'll get the best for multinomial, 82.5% accuracy score. So this is our all complete. This is all complete our model by giving the best accuracy with 82.51%. So again, I'll summarize all the things. Firstly, we are doing our model in four steps. First is data processing, then second is vectorization, third is data training, means machine learning model, we train the data, and the last is deploy the model, but we are not going to deploy it now. We'll do later. So I'm only train the model here. So firstly, we are removing. Firstly, we'll do our data cleaning part. So remove HTML tags, special characters, and convert everything to lowercase. Removing stop words, stemming. Then we use count vectorizer to count every unique word into our